but we seem to be back on track now. And for those who asked, we'll have the listening devices momentarily. So, my name is Edward Davis. I'm the curator of fossil collections here at the UO Museum of Natural and Cultural History. And I'm going to introduce your speaker today. But first I want to promote our membership. If any of you came tonight are not museum members, you should consider becoming one today, as we've just started our Love Science promotion in the museum store, offering 20% off to members on some really cool science-related products in honor of both Darwin's birthday and Valentine's Day. Remember, Darwin's birthday is coming up on the 12th of February, and we'll actually have an event at the museum with cupcakes. So, around lunchtime, if you're interested. Yeah, for Darwin's birthday. Today I'd like to introduce our speaker. Dr. Michael Murphy is a professor of biology at Portland State University. A native of Western New York, he received both his MS and PhD from the University of Kansas. And after teaching for 12 years at Hardwick College in New York, he moved to Portland in the year 2000 to join the faculty at Portland State University. His research focuses on the population biology and behavioral ecology of migratory birds, recently completing a 12-year study on the eastern kingbird, a long-distance migrating bird that breeds in North America and overwinters in South America. His latest research project examines birds living within the extensive forest park system in Portland. This work is just beginning and will include the impact of domestic cats on nest success and the influence of landscape structures on populations living in isolated fragments of urban forest. From 2009 to 13, Murphy was editor-in-chief of the Auk, the Journal of the American Ornithological Society. And that's no small feat. And he has himself published in a number of scientific journals, including Animal Behavior and Ecology. You can always judge how important a journal is by the size of the field that it describes. So something like ecology is going to be on the higher end for those who are science aficionados. Okay, Dr. Murphy has studied birds and habitats ranging from Oregon's Malheur Wildlife Preserve to the tropical island of San Salvador in the Bahamas. After 35 years of outdoor adventures, we're sure he has some amazing stories to tell. So please join me in welcoming Dr. Murphy. Thank you.
Thank you very much. Thank you that February 12th is not only Darwin's birthday, but it's another very, very important person in American history. Abraham Lincoln, that's right. And Darwin was an abolitionist, and so they just... Yes, so I am a population ecologist, behavioral ecologist, working primarily with birds. And I got into migration only relatively recently, and I, like a bunch of other people, jumped on the bandwagon because a lot of new technological advances came forward which allowed us to begin to ask interesting questions. And so I'm not really a migratory biologist per se, but you know, it's nonetheless something I've been able to dabble in, and some interesting things have come out. And what I want to do today is kind of give you a broad overview of some of the important elements of migration, and then get into discoveries that have come out of these new technological advances. And some of them are really, in my mind, quite extraordinary. And we'll highlight those sorts of things. Okay, so as noted earlier, I grew up in Western New York. This was what I was accustomed to for 3 to 4 months of the year. We may be in this soon here also. We've got a storm coming apparently. But for me, the harbinger of spring was an American robin. So when I look out my backyard and I started to see robins around, then I knew spring was coming, all right? And that was always a glorious day. I love the snow, but nonetheless, spring was always better. Baseball season, right? Migration is something that is a phenomenally interesting and stunning experience. Here are snow geese, and I can't begin to count how many snow geese there are. Here's flocks of shorebirds. Again, you know, an impossible number to try and count, but it's just something it's existed for millennia. These birds have been doing it forever. All groups of birds do it, just about all groups of birds. Here are raptors in Mexico that are flying down along the coast of Mexico, where they get squeezed in between the ocean and the mountains, and they pass through in thousands. In a day, you can see thousands of these guys. And then in Nebraska, sandhill cranes. This is an event that is wondrous, and fortunately the local community has taken it on their shoulders and turned it into a major tourist event. So every spring this becomes a major event in Nebraska that attracts all sorts of people, including Jane Goodall, who in fact said, "My favorite place to be is on the Platte River, looking towards the sunset where the cranes come in." all, speaking kindly of things. For me around here, this is what tells me spring is coming. The turkey vultures. And why turkey vultures? Let me throw the question out. Why turkey vultures? That's right. They're scavengers, they eat carrion, and until that gets warm enough to start to decompose and wafting up those odors, they're not going to be around. So it's starting to warm when you see these guys around. And then one of the amazing things of spring migration that I've never been able to experience, or never have yet to this point, hopefully I will, is something called fallout. Okay? And if you live along the Gulf Coast, Gulf of Mexico, in the springtime, it happens fairly regularly, but when these birds come through in these enormous flocks of high diversity of species, if they encounter headwinds that slow them down, they hit that coast, they are exhausted. And they just drop out of the sky wherever they are, and they have to begin to forage to feed them. Rose-breasted grosbeaks, and I think one little black-headed grosbeak sneaking in there, but one species here. But if you take a look at this is Machias Island at a lighthouse during spring migration, and it was an unfortunate weather pattern that they ran into. They didn't want to end up here, but they did. They were forced down. And if you look here, you can identify at least 7 different species of warblers. Okay? This is a point I want to make right now, and this is a very relevant slide for doing that. Mortality during migration can be very, very high. This is the period of year in species ranging from songbirds to raptors to cranes where the highest mortality occurs. This is not an easy task for them to complete. And your average songbird has about 50% survival and probably 75-80% mortality. So birds, for me, are equate to movement. And there are all sorts of movement patterns that I'm going to touch on and mention briefly and get through this, but it's important for us to identify different sorts of movements. And one that I want to make sure we know of right now is dispersal is not equal to migration. So when we talk about, in recent years, human migrations out of the Middle East and all that, for a biologist, that's wrong. That's a dispersal event. A dispersal is a movement in one direction. You go there and you don't come back. A migration is a round-trip movement. You go one place and you return to that place. Within the movement patterns of birds, we have also things called vagrancy. There are eruptive movements, nomadic migrations. You can read these, all sorts of different patterns of movements that birds exhibit. I'm not going to hit all of these, but a few of them I will. So for instance, vagrancy. It's often said that if you stand in one place for long enough, you'll see every bird in the world. A gross exaggeration, but it reflects the idea that, or represents the idea that birds do move and they end up in places where they're not supposed to be. And so a vagrant is a bird which shows up, usually as an individual or maybe a couple, in a place where it's just completely out of their range. And so scissor-tailed flycatchers, they breed down here in the lower Great Plains, and they migrate down into Central America, but they have been seen in all of these locations. It's usually just one bird, it's there. Those are all vagrants. Eruptive movements are kind of like vagrancy on a massive scale. And snowy owls are maybe one of the best examples of a species with an eruptive movement. They breed far north, and they do migrate down somewhat into lower latitudes, but in some years they just show up well south of where they're supposed to in large numbers. And it's usually associated with a declining or poor food supply, combined maybe with a very severe winter. So things just get really rotten up north, and a large chunk of the population moves south. But then they move back, but they may not do it again for another 5 or 6 years. So it's not a regular movement. It occurs only in relation to an occasional event. A very interesting pattern of movement is referred to as nomadic migration. And the only species of bird that I can think of in today's world that does this is an African species known as a red-billed qualia. And it's an agricultural pest. And it moves in flocks of hundreds of thousands. They'll drop into a field and completely eat all of the grain there. They're constantly moving all around. And in North America, the passenger pigeon was probably one of those sorts of species. They are really interesting. Are you familiar with passenger pigeons? Right. Thought to be the most abundant bird in the world at its time. It's said to have numbered in like the billions, low billions. They would literally, and a number of observers have described this, have flocks that would pass over an area that would go on for over a day, non-stop. It was like a cloud going overhead, and they would just rain feces down. It was just, they were so abundant that there were people who actually were referred to as pigeoneers, and their job was to go out and kill these birds and send them off to market. Okay? So phenomenally abundant, but they're gone. And this is thought to have been that black area, the core range for them, but they would move out over this entire area. And they would move in these great distances because the food that they exploited was unpredictably located one place or another from year to year. All of these species of trees, and these guys were seed eaters, and acorns and beech, they have a phenomenon known as masting. They don't produce acorns or beech nuts every year. Every 2 years, every 3 years, kind of unpredictably. And so these large flocks kind of would send out scouts, I suppose, find out where the food was, and others would then follow. So they're extinct. I don't think we could live with them nowadays. I wish they were still here, but I don't think they would be compatible with us. It'd be too much. So, short distance, long distance migrants. Okay, I've worked with kingbirds. These are two different species of kingbirds. I have a very fondness for them. Cassin's kingbirds. This is a short distance migrant. So it breeds in these areas in the pink, and then it moves down through this area and into the blue area where it will spend the winter. But note, they're also this area over here. That is a permanent resident population, as they are there. So this is an example of a species that's a partial migrant, but it's also a short distance migrant, as compared to the eastern kingbird, which is a classic long distance migrant. It leaves the continent in its entirety and heads from North America, where it breeds, down into South America. And I will later today show you some data that we've collected on the locations where these birds are actually moving. But it's a complete exiting of the continent. Lots of birds do this. Okay, so we've already defined migration. It's a round-trip movement, typically by the same individuals. Lots of things migrate, not just birds. And we talk about insects, for instance. There are migratory insects. I took these slides out. They're cool, but I had to save time, so I probably shouldn't even talk about it. But there's a dragonfly that actually migrates 12,000 kilometers every year. And monarch butterflies migrate from southern Canada to Mexico. Right? These are phenomenally long migrations for tiny little things. And one of the unique things that sets them apart from birds when they do that is that it takes multiple generations to complete. In both cases, 4 different generations have to work through them before you actually get back to your point of origin. So migration is, you see that? It's a little light. Okay, I'll read it then. The consensus is that migration is a tremendously labile character that can evolve rapidly. Okay? And as an example, house finches. They were introduced to eastern North America in 1941. The pet trade finally found out that it was illegal to have these things. So they just released them on Long Island. And within relatively short order, the origin of these birds was Southern California. And within relatively short order, they began to migrate. And this figure here shows the distances that they were beginning to move over about a 40-year period after they were released into the wild. So it's something that can evolve quite quickly. And it is a labile character, but as my friend Bob Zinks pointed out in his paper here, this is a behavior that resides deep within the avian genome. Every avian order, with the exception, and they mentioned here the Neognathus birds, the Paleognathus birds are all the ratites. That's the only group in which you don't find some sort of migratory behavior. So this is something that probably evolved very, very early in the evolution of modern birds. It's not, and so when a biologist talks about the evolution of migration, they're not really talking about an absolutely new event. It just didn't come out of nowhere. The capacities are stored deep within the avian genome. And so it's kind of a reawakening when you see, like with the house finches, they're starting to migrate. Okay? It wasn't a de novo thing. They had it in them. A quick comment about barn swallows and migration. This is a species that's got a huge distribution, as you can see here. I'll just, focus on North America for the moment. So they breed over this entire area, and then they migrate south, and they spend the winter down here in South America. Of course, their old world populations do the same thing. But something happened really interesting about 20 years ago. Suddenly they noticed there was a breeding population of barn swallows down there. Some of these birds decided, what the hell? I'm gonna stay. It's pretty good down here. And so we now have a breeding population of barn swallows down there in Argentina. So they can also drop migration pretty quickly. Okay, so it can start and it can stop pretty quickly. And in this case, a migration becomes a dispersal. And this is really interesting because this is probably an incipient speciation event, because now these birds are no longer exchanging genes with the mother population up north. They have to evolve to a whole new phenology. Molt of their feathers has to occur at a different time of year. It's basically a new species. So why do birds migrate? The classic story is that they're escaping the terrible conditions up here up north. And that was the story for many, many years, and that really reflects kind of our northern hemisphere bias. Okay? And then about the 1980s, people started looking at it a little differently, and they were saying, okay, well, no, maybe it's because there are all these birds that are in the tropics and want to head north to exploit all this sudden availability of resources, insects, as the spring and the summer comes on. So these are the two ideas that are out there, and over recent years, this has become kind of the one that's held sway. But, just jump forward, is it really just those two? Are those the only possibilities? And this paper just came out this past year, and I'll let you in on a little secret. I'm chair of the American Ornithological Society's awards committee for rewarding people with their excellent research, and one of those awards is to give them to a paper that has been published that kind of upsets the apple cart and makes people kind of rethink things, and this is the winner this year. Okay, and in this case, what these authors have proposed is that migration evolves, let's cut to the chase here, migration evolves so that, as they've stated, migratory organisms can travel long distances simply to stay in the same place. Okay? Red Queen hypothesis, running as fast as I can and staying and remaining in one place from Alice in Wonderland. The idea is that site fidelity, breeding in the same place, is extremely important for birds. And we know that from lots of empirical studies. If you can feed these birds, when they migrate, they just don't go back to anywhere. They go back to the same locations in almost all species that we look at. And we can document that there's an actual real advantage to breeding in the same place as to going to someplace else. And so the authors here propose that migration really is something that has evolved to enable these organisms to get out of Dodge when it is bad, but mostly to get back to that same location. They could, if it was just to escape those poor conditions, return anywhere, but they don't. They go back to the same locations where they bred in the past. So a new idea out there, and we'll see how it stands the test of time. So how do we study migration? Well, the very first person to have marked a bird to study migration was John James Audubon. And there was this eastern phoebe that nested outside his door, and he got the idea that, well, I'm going to grab this bird and I'm going to mark it. And what he did was to tie a loop of silver string around its leg. And so he let it go. And next year, another bird was sitting right up there, and he grabbed it again, and lo and behold, same bird. It had the silver string on it. So that was the first known attempt at marking a bird to follow it over time. And since then, some new technologies have emerged, quite a few. And the first numbered bands were produced by this Danish fellow in 1899. And now, around the world, we put bands on birds in the United States and Canada, and I think soon to be Mexico. We all cooperate together, and we trade our numbers with each other, and we, as a large body now, can study migration. And so banding involves lots and lots of different ways of marking animals. And the classic one is simply that and that. That little aluminum band goes on the leg. It weighs almost nothing. It's got an individual number on it, and the information on that is sent to Washington, or I've forgotten, I think it's Ottawa, Canada. And the information is kept track of. Again, we share information across countries. And if anybody finds one, if you open it up, you look on the outside, it says open or abre, which is Spanish for open. And inside, it'll tell you, send to boom. So if you find one, you're given an address to mail it to. Lots of other modifications to the marking program. Those are called patagial tags with numbers. You pull tags that are put on the bird's legs, again, with binoculars and scopes. You can read those too. And then even things like putting a band around the neck with numbers on it. If you go out here in the valley, you'll probably come across some birds with those. That was a little tricky. The first attempts at that were not good and some birds died, but they fine-tuned it now so that they don't have a problem carrying those neck bands. But the problem is very, very few of them are ever recovered. Okay? Now, if you do a focused population study like I do, where, as I told you, birds return to the same location to breed, then you get really high return rates. But if you just have a banding station and you're just marking birds that are migrating through, that's what this reflects. Very low return rate on those things. So, the one exception I can say is with hunters, with waterfowl. And that's because we shoot those birds. And we then recover those bands, and the hunters work very closely with management people, and they get lots of returns on those. And with those returns, we for years have now known that there are different flyways. Okay? So waterfowl migration is probably one of the best known. And it's because of the regular collection of the birds with tags on them. I'm going to go through several different approaches now that people use to study migration. This is a wave of migration that's occurring in the area where I grew up. Okay, so Buffalo, New York is located right there, and Ontario is up here, and there's the Niagara Peninsula. Birds don't like to cross big barriers like oceans and deserts, or even the Great Lakes. And so if they can find a pathway that's over land, they typically do. And so there is a pathway, a land path, and these birds are moving through there. And radar stations can pick up the movements of birds. They're like clouds as they move through. And they can differentiate between birds and insects and clouds themselves. So you can actually, over time, go through archives and look at the signals that the radar stations have at particular times of year, and you can document migratory movements. And Sid Gothrow is a person who's been doing this for years, and unfortunately he's been able to determine that the size of these waves coming through are getting smaller. It's an indication that bird abundance is actually going down. But nonetheless, it's one way to study migration. eBird. Any of you used eBird here? Right. This is one of the newer technologies, and this enables people. It's run by the Cornell Lab of Ornithology, and this is one where anyone who goes out and observes some birds on a particular date and place can send their information in, and it's kept track of by Cornell. And is shown here for scarlet tanagers. This represents over a season the wave of movements as they enter North America and they start moving forward. And this is based upon the reports they get from citizens, just the regular individual out there watching birds. So you can see the wave of migration. And this is being used for scientific purposes. There's a lot of good data here. Isotopes in feathers. Okay? And sometimes things like bobolinks do it twice a year. Okay? But they have to replace their feathers. They wear out. Now, as it turns out, if you look across North America and other places in the world, the rain that comes down, of course, is water, and it's got hydrogen in it, but it has different isotopes of hydrogen, and the proportions of the different isotopes varies predictably geographically. So there's heavy hydrogen and normal hydrogen, and the isotopic concentrations change as you move, and that's what these colors represent, a change in the amount of deuterium that's in water, or water is composed of. Their tissues, the insects take it up, incorporate it in their tissues, and likewise so do birds. Birds typically molt their feathers at the end of the breeding season, where they last bred. And therefore, as they eat those insects and incorporate it into their feathers, it leaves a signature that can indicate roughly where they were when they replaced those feathers. Pretty tricky, cool stuff. So, as an example, these are data from birds not collected, but captured in Venezuela. You pull one feather and you do the analysis of the isotopes. And this indicates that this mourning warbler is primarily taken, most of those birds in Venezuela are from birds that bred there, where it's deep blue. And then as it gets shading towards yellow and green, there are fewer and fewer of them represented from the Venezuela. Tennessee warblers, they're mostly found in, again, these are birds that were captured in Venezuela. They came from birds that were banded, molted their feathers in British Columbia, Saskatchewan, and Alberta. Wood thrushes captured in Guatemala. Okay, most of those birds are from the southern United States, Gulf Coast states. And then painted buntings from Mexico, roughly the same area. So some pretty cool information can be extracted from that. But it doesn't work for all birds. And the reason for that is not all birds molt their feathers on the breeding grounds. And these are two closely related species here, scissor-tailed flycatcher and the western kingbird. And the scissor-tail flycatcher does what it's supposed to do, okay? It molts, then migrates, but the western kingbird migrates and then molts. So it's not gonna work for a western kingbird, okay? Also, this doesn't give us any information on paths that the birds took when they migrated, how long they stayed at different locations, where are the stopover locations, how fast they migrate, and none of those details can be extracted when you just pull a feather. Okay? And so, what has now come to dominate the migratory world is this amazing technology where we're using satellite receivers where we can actually minute by minute keep contact with a bird if it moves, to little tiny things called archival geolocators, which we can strap on a bird's back just like a little backpack that they carry. And as the years have gone by, the technology has improved, and so now we've got these little archival geolocators that are so small, you can put them on a bird as small as 8 to 9 grams, and it can carry it and record information for you. Now, the way in which these things work is that they've got a little, and again, it's put on the back like a little backpack, and they cannot exceed 5% of a bird's mass. And so that bird is carrying a geolocator that weighs 0.45 grams. This is like tiny. But it's got a clock built into it, a calendar, and it's got a photosensitive device that you can see right there that sticks out, and that little device records dawn and dusk. And so if you know the dawn and dusk on a date, with the exception of the spring equinox and the fall equinox, you can tell where that bird is latitudinally on the Earth's surface. So it's been a tremendous boon to the study of migration. This has really been one of the most important things that's happened for ornithology in a while. So we can begin to answer a whole slew of questions that we really never could before. For instance, I'm not going to go through all of these, but what is the actual migration route? How fast do individuals migrate? How far do they fly in a single day? Do they differ between fall and spring? Where are the stopover locations? Okay, connectivity I'll talk about in a little bit. One year to the next, or are they variable in how they migrate? Just all sorts of questions can now be asked, and I'm going to deal with those right now. So, the bigger the bird, the bigger the transmitter and receiver you can put on it, and the more information you can gain. And so here's an example with Osprey, and it's carrying a satellite, communicates with satellites here, and this is a case where you can actually, on any given day, call that bird out and figure out where it is. And this is the log of the migration of this bird on different days. You can watch it move up and down these rivers, okay? And this bird, let's see, what do we have here? 44 migrating days, 170 days. Of those 170 days, it was migrating on 44 of them, and 126 it was stationary. That's the kind of stuff you can get. Really pretty amazing. Sooty shearwaters, okay? This is a pelagic bird. And these guys are known to move long distances over the ocean and stay in the air for long periods of time. But, we really didn't know what they were doing. And these birds are able to carry them all year round. It carries a little satellite receiver here on its back. And as noted here, 64,000 kilometers in a year. And they go from down here in New Zealand, some of the birds, they all tend to come over to the east and then loop back. But one segment of the population ends up and spends their winter, our summer, over here in North America. Another group's over there to Asia. And this just represents 3 different individual pairs, showing in this case they did the exact same thing. These 2 pairs, one went that way, one went the other way. Oh, excuse me, that one that way, that one. Anyway, a lot of individual behavior. This is my favorite. This is just amazing. Bartailed Godwits breed in Alaska. They overwinter in New Zealand. So how did they get there? Well, along the way is Hawaii. Okay, we got there. And there's speculation that, because they never saw them over here in South America, and they didn't see them over here in Asia either. So the implication was they got to be going over water. So, but the problem with Hawaii is that nobody ever really saw them there. So these researchers put satellite receivers on these guys, and what they found was that, go back for a second. They're making a non-stop flight. Non-stop. Alaska to New Zealand. Right? And that's amounting to, roughly 12,000 kilometers, and they do it in 6 to 9 days, depending upon the individual. Yeah. It's amazing. Alrighty. Now, they also have a return flight, which takes them from New Zealand over to the Korean Peninsula area over there, and then they hop back here. So it's about a 29,000, 30,000 kilometer flight. And in total, in terms of days spent in the air, it's only about a dozen to 14 days, and they make that flight. Okay? And they can't, think about it, they can't be flapping that whole time. They're riding winds, that they have to. They wouldn't be able to store enough energy on their body to power that flight. And so they time their movements, and in order to time them properly, they have to be able to predict and use atmospheric conditions. And so what I've shown here is on days when they leave, there are these low pressure days when they're staging but not leaving. And what these low pressure systems do is create these countercurrent flows of air, winds, and that's what they pick up on. They jump off of Alaska, get some heavy winds, and start trekking south. Arctic terns, again, it's kind of the same story. We knew they were in the air for a long time, and they're flying these great distances, and we knew they ended up down here from the north in the Arctic Ocean and these islands here, but now we can see the paths that they take. And about half the population goes over to Africa, about half the population goes to South America in terms of their fall migration. They're doing different things. Why, we don't know, but it's diversity there. And the thing that I like about this most is the distances in the year that they fly. Okay? Approximately 50,000 miles, which is twice around the Earth in 1 year. Okay, now check this out. Let me ask you this. Think about the Arctic tern and the shearwater and even the godwit. What could you not do without for 5, 6, 7 days? Water, yeah. Eating, well, you can go a long time without eating. Water does become a problem. But the U.S. military actually has rules about this. Sleep. You can't keep a person up more than 4 days because they start to hallucinate. Okay? Sleep. Do these birds sleep? Right? Well, the answer is yes. They're sleeping while they're flying. Okay? And some of the best evidence in support of that comes from data collected on great frigate birds. And you'll note it's got that satellite device on its back, but it's also got this thing right here on its head. We're creating Frankenstein's, okay? It's glued on, it can come off. But what that thing does is measure, it's an EEG measurement. It records brainwaves. Okay? And it also records movements of the wings, so you know if the bird's moving or not. Okay? And so with those data, what we've been able to show is that, and these are data collected from birds in the Galapagos, and they were out foraging for 10 plus days before they returned, is that they are sleeping. In fact, birds have the ability to shut half of their brain down and keep the other active. And then they flip-flop back and forth, okay? And that's indicated here by the fact that this bird's eye is closed, that side of its brain is shut down, that eye is open, that side of the brain is active. Okay? At times, they actually shut the whole brain down. They do sometimes go completely asleep on the wing. No? Amazing stuff. Okay. I had to actually cut stuff out because there were so many amazing stories here. But these are European swifts. These guys, walk swift around here, and these are tremendous aerial foragers. They migrate from Europe to Africa, and these are records from fall migration. Fall migration, well, it doesn't matter. 2 of those are migrations, and 1 is the winter, and that's the summer breeding event. Okay, now, these guys have accelerometers on them, so every time their wing moves, they detect that movement. Okay, so the only time these birds do not have wings moving are when they are found down in the center. And you'll note here, this is the breeding season. They've got a nest. When they come down to the nest, they stop flying. But at every other point in the annual cycle, they are never on the ground. So 9 months out of the year, those birds are in the air. They never come to the ground. And they gotta be sleeping. No one's recorded sleeping, but they have to be. Same as the frigate birds, in all probability. Okay, now, The geolocators are a different deal because these are the only things we can yet use on these really small birds. And so Bridget Stutchbury was the first person to do this, and she published a paper in 2009. She was working with purple martins and wood thrushes. And what she showed was that these birds were, as we kind of guessed, you know, some would jump as they migrated, jump the Gulf of Mexico, others went around that. But she was able, for the first time, to really come up with a really close track of the migratory paths that these birds were taking. And these are just, you know, two examples. These are two different birds, and those are two different birds here, wood thrushes and purple martins. These guys are doing pretty much the same things in the spring. They both probably jumped in the fall, but in the spring, this one jumped the Gulf. This one decided, for some reason, yeah, I'm going that way. And she has actually shown that some birds, measured in more than 1 year, will do both of those in different years. But we don't know yet why they decide to go one route or the other. A huge debate for many years in ornithology was what this bird does. It's a Blackpoll warbler. Okay, it weighs all of 12 grams. Okay, that's maybe 2 nickels, you know, something like that. And this is its breeding distribution up here, and we really didn't know where it was migrating. It overwinters in South America, but how it got there, we don't know. You didn't see very many of them along the coast at all. And the suggestion was, by some people thought, well, it's flying out over the ocean. It's doing a flight across the Atlantic. Others said, you're crazy. They're not doing it. They're only 12 grams. They couldn't possibly do that. So some folks recently put geolocators on them, and that's in fact what they do. Okay, they stage up here in Maine and southern Canada, and here's a record of a bird that flew in 2 days' time down to Hispaniola, stopped over for a few days, and then finished off its flight into Venezuela and South America. And that seemed to be the typical pattern for these birds. They're making flights that last on the order of, 2 days, actually closer to 2.5, 3, and continuous flight of 2,500 kilometers. This is a 12-gram bird. What they're doing, of course, is catching the winds. The westerlies blow them out over the ocean, and the trade winds bring them back in. They're riding the waves. Same thing, just one more little tidbit with a warbler here. We knew nothing about Connecticut warblers. Absolutely nothing about their migration, or even where they overwintered. And this is recent. We didn't know nothing about it. And then some folks put geolocators on them, and they found out they're doing the same thing, basically, as the Blackpoll warblers. They're jumping over the ocean. Now, just to summarize a few things, one of the other questions we had was, do they migrate the same speed in fall and spring? The answer is no. Here are data from about 20 different species of birds, and it turns out that in the spring, they're moving a lot faster than they are in the fall. And it makes good sense because spring's about having babies. Got to get back there, got to get territory, got to start breeding, and they move considerably faster in spring than they do in the fall periods. So I've dealt with those. I want to deal with these for a moment. Okay, a little more detail, and hang with me there. I want to describe something that's known as migratory connectivity. This has become a real important issue in ornithology. Migratory connectivity refers to the extent to which breeding populations that are separated, say, in Saskatchewan and Minnesota and South Dakota, remain separate when they go into their non-breeding grounds in wintertime. Do they all mix together, or do they keep distinct units? And we really have no idea what they were doing. So here's a case where we represent strong connectivity, distinct breeding areas. They go down into, we'll say, South America, and they remain separate. The other possibility is that they're weakly connected. So you've got these distinct breeding populations, but when they get down into the wintering grounds, they just all mix together. So what is the typical pattern of birds? What do they do? And honestly, we don't know very well for any of these birds. It's not a trivial matter, though, because whether you're weakly or strongly connected has implications for the ability of birds to adapt to specific conditions on the migratory grounds where they spend the winter. If they're all mixing together, it makes it very difficult for them to narrowly adapt to a very limited range of conditions. They have to be able to adapt to a wide range of conditions. More fundamentally important, maybe, is that it has important implications for habitat loss on the breeding grounds for breeding populations. So if you have a situation like this, and you lose that chunk of habitat that represents their wintering grounds, and let's say forests get cut and that's all gone, it's really not going to affect any single population because they all mixed. But if you have this kind of a situation and you lose that, then you lose that. So understanding the degree to which they're connected is important because it can help establish this kind of management program that may need to be put into place to keep them in existence. So here's an example from a bird called a northern wheatear, which shows low connectivity. Low connectivity is when birds mix on the breeding grounds. And here, again, phenomenal. Alaska population, over here in eastern Canada, these guys take that route over. These guys fly all. And the colors simply represent where birds from that area spent time. You'll note in all three. From eastern Canada, likewise, birds spent time in all three. So they're mixing completely together. This is weak connectivity. Bobolinks, this is a bird, the songbird in North America, which has the longest migration. They go all the way down to Argentina. A good friend of mine, actually I got a whole bunch of friends who've done this work. They worked two different teams, one in Vermont, one in Nebraska, put geolocators on a bunch of birds. Fall is represented by the brown, spring by the green, and winter is blue. So they all end up down here in the same location. Okay? This is a weakly connected bird. They mix together from all across the breeding range in the same area. And in addition, they do the same thing moving south. They completely mix together. There were some really noteworthy things coming out of this though, and I want to highlight that. 1,900 kilometers in one day. One bird flew. He rode winds, didn't fly, he rode winds, but covered 1,900 kilometers in one day. That's extreme. Okay, now, something else we didn't know about is whether or not birds move when they're down there. Do they all come down and become territorial and stay in one place? Or do they move about? And one of the first species that was studied that demonstrated that in fact they're using more than one location was the veery. And so a bunch of birds were marked from one population, one little tiny population in Delaware, put these geolocators on them, and those birds then came down into Amazonia here, and they both, every bird there used two locations. So the 5 birds shown here all ended up in those locations for about a month and a half, and then boom, they all switched and went somewhere else. And then from there, took off for North America. But they spent substantial amounts of time. And this represents IntraTropical migration. We didn't know they did this. Okay? But it turns out they're not the only ones. Okay? Excuse me. This is a bird that I've spent most of my time working on, and I was involved in this study. And what we found from birds marked up in Nebraska is that they do make their South American flight. They all end up south of the equator, to at least some extent. And we have data we have 8 records here from 7 different birds. And this particular bird, we actually didn't catch the first year back. And it made a second migration, and we got it back the second year. We have 2 years of data for that bird. And it did the same thing in both years, exact same thing in both years. But all of those birds had a first location where they spent time, indicated by the blue dots. And then every bird, except the bird that we caught twice, moved to a different location. But every bird, every one of them, ended up in a location right up in there where Peru, southern Ecuador, every one of them. So that tells us that that region is probably an extremely important overwintering site for these birds, and therefore we need to pay attention to what's going on there. And maybe, if things get bad, work with the government down there. We also, in another study, marked birds from Oregon, Nebraska, and New York to examine the extent to which they showed connectivity. And it turns out that these guys pretty much overlap. Okay? The New York birds and the Nebraska birds pretty much did identical things. Ended up down here, okay? And then in both populations, they moved north, ended up in that area around northern Peru, Ecuador, southern Colombia, in the same location. That's where the Oregon birds spent their entire winter. They didn't move. But they did use the exact same area where the birds from the other populations ultimately ended up. So clearly that is an important area for kingbirds. Okay? Here's an example of where we can use these kind of data to establish that there's actually a genetic basis for what they're doing. So in the hermit thrush, this is its breeding distribution, okay? It goes across North America. There's a coastal population over here. They're called the russet-backed thrush. Most of the birds are olive-backed thrushes. And the question was, do they behave differently during migration? As it turns out, they indeed do. Right? The inland birds fly inland. The coastal birds come down the coast in both spring and fall. They don't overlap in their migration at all. But where they come together in British Columbia, they do breed with one another. So then the question is, what are the intermediate offspring doing? Well, wouldn't you know, they're doing intermediate things. Okay. And really interesting, okay, so stay with me on this one. When they actually genotyped these birds here, they can carry alleles from either the coastal population or predominantly the inland population, and each point represents a different individual, and the more of the inland alleles, the genes that they carried, the more inland-like behavior they exhibited. So you can see it's not a switch, it turned just on and off, black or white. It's a graded phenomenon, and it reflects the degree to which they represent one population or the other. It's a clear genetic signal is going on here. And also, this is one of our first examples of where we actually have high connectivity, because those different breeding populations end up in different places. So every example I've shown you so far is low connectivity. Here's a high connectivity population. The last example. Blue-winged and golden-winged warblers. Phenomenally beautiful little birds found in eastern North America. Have gathered attention from biologists for many, many years, mostly because they hibernate. And they produce distinctive phenotypes, common enough that at first they were described as different species. So there's the Lawrence's warbler and the Brewster's warbler, and they, in fact, there are intermediates of those too. So that got a lot of interest from biologists for a long, long time. But as it turns out, in recent decades, last several, we've seen population declines, pretty serious ones, in the golden-winged warblers, whereas the blue-winged warblers were, stable or even increasing. And it wasn't known for the reasons for that, but a number of hypotheses were proposed for the golden-winged warblers. One was they were losing habitat on the breeding ground. They breed in early successional shrub in the Great Lakes states and down through Appalachia there, and they all overwinter in Central America. Now, these lines are not direct flights. That's just connecting birds. Okay? But they all end up here. The blue-winged warblers, golden-winged warblers, they breed in the same areas, okay? But different than the blue-wings, the birds from the Great Lakes states go to Central America, but the birds from Appalachia go down to over South America. Okay? That's another highly connected species. And this takes a little working with me here. What we've got shown here are data for the blue-winged warblers from the Lake States and Appalachia, golden-winged warblers from the Lake States, and the golden-winged warblers from Appalachia. Remember, these two populations overwinter in the same area. Those diagrams, those histograms, represent forest loss on their wintering grounds over about a 60-year period. Loss of forest on their wintering grounds. Those data represent population trends for breeding populations in North America. They're all going down, but really fast in the golden wings. Okay? That number represents the degree of the strength of association between that trend in numbers on the breeding ground and loss of winter habitat. And it's significant in all of them. You lose winter habitat, breeding populations go down. But in the golden wings that are in Appalachia, it's really, really strong. Maximum value could be 1. They're almost right there. And so clearly, with these guys, loss of habitat on the non-breeding grounds is having significant influences on their populations, but especially for the golden-winged warblers in Appalachia. Okay, so I don't even know how much time I've taken, but I want to sum up with a few statements here. And the first of these is that, if you can't read that, birds are amazing and awesome in a real sense of the word. We use that word awesome too loosely nowadays. The stuff they do is truly awesome, okay? And for them, the world truly is their oyster. I mean, they just move in ways we cannot imagine. And it's our ability to discern this has only been made possible because of technological advances that have happened in the last couple of decades. It's just opened up our eyes. It's just a totally different world. I started graduate school 40 years ago, exactly. 1978, 79 was my first year of beginning this stuff. And honestly, when I look back on it, that's the way I feel. Stone Age, okay? Hand axes, okay? And now, the changes. This is really, it's revolutionized that we're doing and asking questions. And it's not just with the stuff I've shown you. The molecular biology that we have nowadays that allows us to ask stuff is just absolutely transformed us. So when I honestly think about how our understanding of birds has changed over 40 years, it's just blows me away. And if I try and project 40 years in the future, I can't even begin to think what's going to happen. But I can't imagine it slowing down. So we've learned a lot of really amazing things. And one is birds sleep when they're flying. You know, I mean, that's, you know, an amazing thing that they do. 9 months up in the air without ever coming down to the ground. We also know that some of these birds, because the Arctic tern, for instance, can fly around the world twice a year. I mean, the distances that they can fly is truly astounding. Even these little guys can fly great, great distances with the assistance of winds. And these little guys, they undertake flights over large bodies of water that really people never thought were possible. And within the tropics itself, we find out that birds are moving from one location to another. And until 10 years ago, that was an unknown. And then one of the things that we're beginning to identify, and I think this is important because a lot of this stuff is, you know, in a sense esoteric, and just learning about the biology of birds. Now, I think that's really important. Other people don't. But as shown by the last example with the warblers, it has real conservation implications because we now can be able to connect population changes with phenomena that are going on during either migration or during the period when they're not breeding and they're on the wintering grounds. And it's really important for what we now are calling full annual cycle biology, completely understanding what these animals are doing over the 12-month period. And that's really what we need to do to put in place effective conservation programs for these birds, the warblers, and others too. So there are lots of things still to be learned, and I think many of them, you probably read these so I won't go over them in detail. A lot of them involve climate change. Birds are changed substantially. I mentioned earlier that the most mortality in birds that are migrants occurs during migration. And with changing climates, we're going to see increasing severity of hurricane seasons in the Gulf, for example, and those have major impacts on birds. So getting a better handle on how birds will deal with that is something that we're going to have to put a great deal of effort into. And I think also identifying for more species where they are so we can begin to synthesize and for many species put together maps of high priority areas that need our attention. That can be gained with the kinds of studies that I've been describing here. And then the last thing is we're finding out that the kinds of experiences they have down on the wintering grounds, how fat they are, what kind of condition they are, which is based upon the resources they're exploiting there, carries over to the breeding season, and it affects their reproduction thousands of miles away. So the connection between winter and down breeding through migration is a major phenomenon of which we're learning a lot, but there's still a lot more to learn. Thank you.
We got started late, and so I think some folks might want to go, so we're going to give you just a couple of minutes to move out if you want to, and then do some Q&A. I apologize for the start late. Thank you very much. That was great.
I'd love to take as many questions as you can throw.
All right, so let's go ahead and have some questions. You get it.
Yes.
So those little things on their backs, do they have to have batteries in them, or are they running on solar, or what?
Okay. So the question is how the geolocators are powered. Do they have a battery or is it solar powered? And at present, they're battery operated. And therefore there's
Is that because we do lithium now?
well, they're,
Or is there something more advanced than lithium?
you're probably pushing me into an area I don't know enough about to answer knowledgeably, but the solar ultimately would be the better way to go, because of course they can keep recharging, but for those little tiny things, the technology is not there yet to use solar. And the smaller the size of that geolocator, the shorter the lifespan.
Yes.
Yes.
Is it an average flight height?
I'm sorry, Dina.
An average flight height?
Oh, okay, so the question was, what is the average flight height? How high above ground? It varies with the group of bird you're talking about. So songbirds, like the warblers, they're typically going to be flying a few thousand feet. But you get into geese, they've been seen flying over the Himalayas. You know, so lark and ducks are kind of intermediate. Waterfowl would be intermediate. Yes?
I know there's different arrival times into the nesting areas as well as different departure times from the nesting areas for both juveniles and adults as well as males and females. So are people tracking the male, female, juvenile, adult as well?
Okay, so the question was, are we dealing with basically the diversity? So within populations, we have males, females in different age classes, and are we asking questions about arrivals and departures based upon those? And the answer is mostly not yet. We will get there, but most people have focused on males because males are less involved in reproduction. They're involved, certainly, but females are really, if female abandons, then basically it's a failure. And so I think that's been the primary reason why we haven't gotten there. They're beginning to do some things with younger birds, but not enough data yet to say much.
You had that data that showed one individual went across the Gulf and another individual went along the coast of Mexico. It looked as though they also were at different times. One was in April dates, the other was May dates. Do you think there's any chance that the path they choose reflects when they meet?
Okay, so the answer is yes. The question was whether or not they take a direct flight across the Gulf or take the longer flight along the coastline is a decision maybe based upon some aspect of the boundary. And I can tell you from my eastern kingbird work, we had one male, one of the birds that we actually got data from in 2 years. In 1 year, he jumped across the Gulf, and another year, he went around it. The year he jumped the Gulf, he took off late. I think he was making up time. So I think that probably is an important element there. Somebody here had a question.
We talk about birds that breed north of the equator and overwinter south of the equator. Are there breeding birds in South America and Africa as well?
Interesting. So the question is, we know a lot of birds breed in the northern hemisphere and then head south and cross the equator and overwinter south of the equator. Are there birds that do the opposite? That's a question that's only been dealt with maybe over the last 10 to 15 years. And yes, the answer is yes. There are birds from, say, southern South America. None of them come to North America to breed, but they will breed during the southern summer and then cross the equator and overwinter as far north as Venezuela. So they stay within South America, but they do a comparable movement, north-south. In that case, south-north. Far back, yes?
Hey.
Yes?
Yes, so, for example, that species had some that cut far inland and some that right out, and then the middle ones kind of came together. So I'm wondering what it is about the genes that is causing these individuals to go in the middle. So, like, what is it that the genes are doing?
Okay, so the question is, we know that we have birds which are of intermediate genotype, which are doing intermediate behaviors. And if I got you correctly, how is that actually mechanistically occurring?
Yeah, so what is that saying about?
Haven't got a clue.
Okay.
and I don't think anybody does.
Okay, that's, yeah.
Not at this point. Maybe down the road, 40 years from now, as I was saying. Yeah. At this point, we don't know.
It's just a correlation.
Yeah.
Let's do one more.
Okay. Yes, ma'am.
This is kind of a local question, but in here in Cottage Grove, there are wires and trees where thousands of birds will be along. You can't see the wires because they're covered with black birds. So what are they doing? Are they staging and getting ready?
Well, the question was near Conyers, you said it was? Conyers, okay. So the birds are lining along the weathers. It would have to know what time of year. that was happening to have any idea?
They're right now.
They're right now. Okay, so what I would suggest is that they're probably gathering together, possibly birds coming together. They can kind of check each other out. And they can kind of, this is like speculation, but they can kind of say, okay, Bill over there looks pretty good. Jane over there is not looking so hot. Tomorrow when I go out and forage, I'm going to follow Bill. So there's, people do think that one of the advantages of coming together in those groups on a regular basis is to evaluate each other, to gain information about where it might be profitable to forage. Well, thank you.
Thank you very much. I want to ask you to please join us next week for the second of our Darwin lectures. It'll be by Dr. Julia Clark from the University of Texas in Austin on the secret lives of dinosaurs, exploring the evolution of dinosaur feathers and how recent fossil discoveries are changing our views on how these ancient creatures looked. I'll tie in with our archaeopteryx exhibit. Thank you for coming out tonight. I appreciate your time.